Assalamualaikum warahmatullahi wabarakatuh. So, video ni kita akan bincangkan example 6, learning outcome 5.4b, use Lenz law to determine the direction of induced current. So, example 6, does the loop of wire have a clockwise current, a counterclockwise current, or no current under the following circumstances? Example 6a, the circumstances is the external magnetic field points into the page and its strength is increasing. So, very simple, B external increase. So, initially, B external sedikit, kemudian dia bertambah. So, kita boleh nampak dalam gambar yang saya berikan ini, the number of magnetic field lines into the page increase. So, ke manakah arah direction of current di dalam coil yang berada di dalam magnetic field ini? So, yang pertama sekali, soalan dah bagi, the external magnetic field points into the page. Since the external magnetic field increase, therefore magnetic flux also increase. Now, graphically kita boleh nampak daripada diagram ini, pada diagram yang pertama, number of magnetic field lines dalam area ini ada 4, manakala dalam gambar yang kedua, number of magnetic field line increase. Now, magnetic flux can be imagined as magnetic field lines that pass through an area. So, di sini kita nampak magnetic flux bertambah kerana the number of magnetic field lines bertambah. So, magnetic flux increase. So, kita apply right hand grip rule pada salah satulah daripada gambar ni. So, yang pertama sekali, the external magnetic field is into the page. So, apabila magnetic flux increase, maka kita kena terbalikkan tangan kita kerana magnetic field produced in the coil or induced magnetic field oppose the external magnetic field into the page. So, the induced magnetic field is out of the page. And the current can be determined by looking at our fingers. So, dalam kes ini, the fingers is anti-clockwise. So, itu soalan 6A. For question 6B, the external magnetic field points into the page and its strength is constant. So, dalam kes ini, sebelum dan selepas adalah sama. The number of magnetic field lines that pass through the area are equal. Okay, so tidak ada perubahan magnetic field. So, B external is constant. So, walaupun kita tahu ada external magnetic field into the page, but there is no change in magnetic flux. Okay, so no change in magnetic flux. Therefore, there is no induced magnetic field and no induced current. So, tidak ada juga induced EMF. Okay, kerana external magnetic field constant. Therefore, there is no change in magnetic flux. So, soalan B simple. Lebih simple daripada soalan A. Manakala soalan 6C, the external magnetic field points into the page and its strength is decreasing. So B external decrease. Visually kita boleh tunjukkan dengan gambar ini sebelum dan selepas. Dalam kes ini kita nampak bahawa the number of lines that pass through the area is decreasing. So magnetic flux also decrease. Okay. So we use our right hand grip rule to determine the direction of induced magnetic field. So initially the magnetic field masuk ke dalam. Apabila magnetic flux decrease, the direction of induced magnetic field is in the same direction as the external magnetic field. Therefore, by using our right hand grip rule, we know that the direction of current is indicated by the fingers. So, finger saya berada pada menunjukkan arah clockwise. So, B induced is also into the page. And the current is clockwise. Okay, so into the page ni maksudnya dia sama dengan B external. So, itu sahaja dalam video kali ini. Kita akan bincangkan example 7 dalam video yang seterusnya. Sekiranya ada apa-apa yang tidak faham, bolehlah tanya saya dalam kelas nanti. Okay, so take note, tuliskan dulu apa yang kamu tak faham di mana-mana. Mungkin di bahagian depan nota kamu. Dan tanya saya dalam video yang seterusnya. Itu saja. Terima kasih.